Thanks. Now that sounds pretty easy. We're going to put a little algebra in there too, just for fun. Okay? So, all right, the distance between 2 points. Let's just, sounds easy enough. Let's just define it in math terms here. The distance is the absolute value. I'm going to stop there for a second. Absolute value is always going to be what kind of number? Positive, because what is absolute value? Do you remember on a number line? McGregor?
How far away it is from zero?
Yeah, it's just how far a number is from zero. I have a number line. I got to put it up. So if I'm at 3, 3 is 3 away from 0, correct? If I'm at -7, how far is that away from 0? 7. Okay, it's not talking about what direction it's in. It's just how far it is from 0. So distance is the absolute value of the difference, meaning you subtract, between 2 points. It's always a positive number. I just got my nails done yesterday. There's little stripes, but you can't see them. Okay, see it? Sorry. I get distracted. Okay, so here is how you can write that as a little equation here. So you have 1 point. You're going to subtract where the other point is and take the absolute value of it. And that gives you the distance. 2 points, subtract them, take the absolute value. And that's a distance.
I don't like that.
Oh, don't be worried about that. That's it's just showing you. Not sure how much you'll actually use that, but we'll see. Segment addition postulate. So this is just a postulate, it's just a theory we accept to be true. You don't have to memorize it, but I'm going to show it what it is. If B is between A and C, is that true in this picture? B is between A and C, yes? Okay. If that's true, then we can say that AB plus BC equals the total AC. Simply means you're adding this piece. I'll wait till everybody looks. It just means you're going to add this piece and that piece, and it'll give you the total. Okay? Now, I'm wondering if any of you are wondering why I don't have lines above here. Maybe not, but
Because you're talking about
there's,
points.
right on, Courtney. She is right. Okay, there is a difference between writing this with a line above and without a line above, so I'm just going to do this. Side note. Notation is important in this first chapter of geometry, okay? So when you do this, that means you're just referring to that segment. Okay, that means you're referring to segment AB. But when there's no line, it means the distance between A and B, or how long it is. So 2 different things. I know it seems trivial, but in geometry it's what it means. When you have a line over above it, you're just talking about that segment. When there's no line, you're talking about the measure of that segment, how long it is. So that's why there's no line here. However long AB is plus however long BC is gives you how long AC is. Cool? All right, turn the page. All right, use the segment addition postulate. It means we're going to add two segments together. That's what that means, to find the distance from Athens to Albany. We're talking Georgia here, apparently. All right, so I'm going to write it out because that's what we're doing today. I'm going to say, all right, I have to find the distance between Athens and Albany. That means I'm going to add AM plus MB, and that's going to equal the whole thing AB. That's using the postulate, and then I can fill in the numbers. So how far is it from A to M?
80 miles.
And here is 90. So what's the total? Let me do that in their head? 170. Just add 8 and 9 and put a 0 at the end. 170 miles. Let's be appropriate here. 170 miles. Cool? Really, it's just adding stuff, but it's just using the right notation. Okay? Okay, we're going to talk about the difference between congruent and equal. It's not a difficult concept, but I have a PowerPoint for you. Isn't that exciting? Okay, so here we go. Vocab, congruent. Equal is represented by numbers and lengths. They have the same value. Congruent is when you're talking about actual objects, like segments, and you're not putting a number attached to it. Segments, angles, shapes, they're the same size and shape. But we're not actually talking about that number. So let's use this diagram at the right. I don't want to go too fast. All right, are the segments congruent? That means, do they appear to be the same length? So we're looking at DE here. How long is DE? Can you tell? How can you tell? Okay, this is why you don't sit next to each other. Stay with me. What's one easy way to figure out how long that is? McGregor.
It's 4 squares long.
Yeah, 1, 2, 3, 4. Easy, right? It's 4. How long is this one? 4. Okay, so I know they're congruent. They're equal. So I can just say, yes, they're congruent. I'm going to say, yes, they're the same size. So therefore, I could say segment DE is congruent to segment DG. And that's all I'm talking about. I'm not talking about a number there. I can just see that they're the same length. Then, are the segments equal? Yes, because ED equals FG, because 4 equals 4. No line over above if I'm talking equal. All right, turn it over. Okay, this is kind of just a checkpoint. It says find AC, so I'm going to use that addition postulate. I'm going to say, okay, I'm going to add AB plus BC, and it's going to equal AC. AB plus BC, 14 plus 6 equals 6. Does it equal 6? What does it equal? 20. Oh. AC equals 20. No line above because I'm assigning a number to it. So that you don't put a line here. Okay? All right, find ST. Oh, look at this. How would I have to do that? What would I have to do? EJ. Yeah, you can easily see it's 23 minus 15. But I'm just going to kind of write it out geometrically here. So the addition postulate says, if I add this one and this one, I'm going to get the big one. I don't know what ST is, so I'm going to leave that like that. I know TR is 15 equals SR, which is, I'm sorry, 23. Boy, I need to go back to bed. SR is 23. Okay, so all we do now, like EJ said, is we just subtract 15 from both sides. ST equals 8. I got to add a problem on. That's because, let me just make sure. Yeah, we do, because we got a little bit of algebra we have to add in here. What? Okay. I'm making one up. So you're going to have this. Let's make it DHS. Let's make this segment x plus 4. I'm just making this up. We'll see how it works. We'll make this 2x. And we'll make the whole distance between here, let's say, well, let me scribble this. Let's just do ds is equal to, I don't know, 20. So ds is equal to 20. Okay, can I solve for x? Do I have what I need to solve for x?
Yeah.
Take a look at that. What do I do? What do you think, Christian, what do you think I would do to set this problem up? Pardon me? Okay, so he wants to subtract that, right? That was what you were thinking? We could maybe, but I'm not sure that's going to work right now. What does this tell me? This tells me this whole thing is equal to how long? 20. So if I add this together and this together and set it equal to what? 20. Let's see if I have an equation I can solve then. Okay, EJ.
I believe.
You do? Just let us all find that together. So I took x plus 4 and I added 2x and I set it equal to 20. What do you have to do over here first? You got 2 x's, right? You got to combine them. How many x's do we have all together over here? This 1 and these 2. So I have 3x plus 4 equals 20. Subtract 4. It's not going to be even. I tried. It's okay. What'd you get, EJ? I don't have a calculator in front of me. Oh, you're guessing in your head? This is going to be if 16 over 3. I don't know what that's equal to. But then you would take whatever that number is and add it to 4 to find this length. And multiply by 2 to find that length. Yeah? Algebra. Which you spent a whole year with last year.
Unfortunately.
Okay? All right.